Hi, good morning, and welcome to the ZP Developer Zone webinar. So we do this Developer Zone webinar every Thursday at approximately 8 a.m. London time. I must admit we've gone early today. It's just increasing numbers of meetings, and so we find ourselves going earlier and earlier. But my apologies for that. But I will go forward, and I'll also speak quite fast because there's plenty of things to cover today. The first thing to say that don't forget we do have our free ZP Academy. And I realize I don't put a link to this anymore, but I have had some feedback that people are finding the material that we're putting out on ZP Educational, and there is actually a ZP Academy, and there's at least 2 free courses on that, which are definitely worth a look. Webinars, this is an example. We do webinars every week. In fact, now we're doing webinars 4 days a week, weekly webinars. One on our Sense It All platform. So Sense It All is a really good technology for, let's say you were making a MIP in a lab and you were using it to make some sort of non-steroidal anti-inflammatory drug detection system. The Sense It All platform will really quickly get you actually to what's called a minimally viable product, and actually you can start clinical trials off that. Anyway, so we do that on a Monday. On a Tuesday we do Julie. Julie is a proprietary cloud system. You can open up a freemium account. It's really designed for receiving electrochemical data. On a Wednesday, we do Food Sense. So there'll be some videos today about repeatability. And it's really important that ZP has really repeatable screen printed electrodes. And that's because we need them for that Food Sense product. So you will find on Wednesdays that we will do a FA frequently asked questions session on Food Sense. On Thursdays, we do this webinar. And then, wow, there's a break on Friday. Let me go forward a little bit quicker. I was being asked this morning actually about collaboration. So in fact, we do a lot of collaborations. We support what's called CDT, Centers for Doctoral Trainings in the UK. I was just being asked this morning on LinkedIn whether we have positions, and I did say there, follow us on LinkedIn if you want to know about open positions. They get essentially posted by our HR department. We do have the ZP Developer Zone, which is a website sort of dedicated to developers, and then we do have workshops. Some of the questions that have come in today, we do workshops on wearables. Microneedles are covered there as well. So we do in-person workshops, and they're very practical, and we're going to do one next week in Grenoble, and then so that's the October one, and then there's one also in November in Norway. Going forward slightly quickly, here are those workshops. If a link jumps up, by the way, I am going to put the link underneath the video afterwards as well. So there is a workshop in Grenoble next week, and we look forward to doing that. It's on Tuesday and Wednesday, and then we do have a workshop in Horton in November, and I know I think it's approximately around about the 15th of November, but I'd have to check that link to really check that out. We did have our Scandinavia Sensor Summit, so we have now a new effort. We call it S Cubed, which stands for Scandinavia Sensor Summit. This is really just a series of things like conferences. So we do have a couple of upcoming conferences, one in the UK. So if you are UK based, specifically kind of in that sort of Loughborough, Leicester, Birmingham, Coventry areas, please keep a real eye out for this one, because it's 19th to 20th of June 2024, and the theme of it will be the commercialization of electrochemical assays. And there is another one in Norway on the 22nd to 23rd of January 2025. This will be around precision agriculture, and at least the one in Coventry, there is an early bird interest registration, and I've got a link here as well, so you can show some early bird interest. As I said earlier on, we do a whole bunch of, let's say, free webinars. So this is a link here. I said we do at least 4 webinars a week. We actually do also monthly webinars, and these are definitely worth coming, because here, whenever we do a monthly webinar, there's always a live demo. I mean, if I do a webinar like this, I might talk a lot, but there's nothing like seeing. So we have a one on Julie. I really want people to sign up for that. So there is a link here, and I will drag myself out of the way of that link, because I think it's important. There's one on Julie, there's one on the Sense It All platform, there's one running in India on data sciences for biosensor developers, and there's Food Sense here. So there's a link here. You can click that, which I will put underneath this video on YouTube afterwards, and you'll be able to sign up for those, and those are free. So questions this week. Question number 1 is about hypervalue electrodes. So ZP, we have a really repeatable hyper value series of electrodes. They're really repeatable because I'll talk about repeatability a lot today, but they're repeatable because we are the biggest users of these electrodes. I was saying to a client yesterday, the first people to know that these electrodes are not going to be brilliant is us, because we've actually done so much testing, and that will be one of the questions today. Somebody wants me to talk about the Biosensor starter kit. The Biosensor starter kit, I feel like, was something that we were sort of doing almost, yes, almost COVID time. So it's quite an old product line from us, but I'll talk about it. I'll also talk about repeatability of our screen printed electrodes. I know it's so many people get these screen printed electrodes and they're not ours, but they complain about repeatability, and it's just amazing because at ZP we've really worked on repeatability, but I have some data to sort of test that. I'll make a comment on testing blood, and I'll sort of do it specifically on glucose, and I'll also talk about wearable microneedles. It's probably worth saying that when I talk about Biosensor starter kit today, I'll use glucose as the example. Testing in blood, I'll use glucose as the example, and wearable microneedles, I'll also use glucose as the example. But let me go forward a little bit faster. So we had some questions in about the hypervalue electrodes. We do them in hypervalue platinum, hypervalue gold, and hypervalue carbon. They're essentially all the same in terms of, if you zoom in on them, they've got a working electrode, which is either carbon, platinum, or gold. I will talk about pricing in a minute, so I do want you to just bear in mind that carbon is an order of magnitude lower cost. The counter electrode here is silver chloride, and the reference electrode wrapped around that working electrode is also silver chloride. I have other videos on this, but it's really important that those material selections are not by randomness. Many people have the counter electrode as some sort of nominal material, like, if the working electrode is platinum, then they make the counter electrode platinum. This is a really bad idea when you make small volume measurements, because you don't know what's happening on the counter electrode all the time. And actually, when the volume is very small, what's happening on the counter electrode becomes really important, because actually within about 15 seconds, what's happening on the counter electrode can be diffusing to the working electrode. And so I've seen this kind of chemical closed loop where materials on the counter electrodes, which are generated during the experiment or the analysis, end up diffusing to the working electrode and causing a close or feedback loop, which then generates more reaction, let's say, on the working electrode, that generates a counter electrode. And that's what I mean by a feedback loop. These materials are chosen because of their inertness and also their insolubility. So it's not by randomness or accident that those materials are chosen. And I think it's because really at ZP we're the only people with, I would say, real world experience, with some of us going back over 20 years. And I mean real world experience making medical diagnostics in industry. I've done it multiple times. These are the dimensions of the electrodes. Not so important. I would actually just say get hold of them, try them out, especially on the repeatability. So here's some useful links. Here's the carbon, here's the gold, and here's the platinum. I realize I've got one, so I'll just wind up a little bit. So we can do 300 electrodes for 250 euros, so it makes it 83 cents per electrode. We can do 100 gold electrodes for 650 euros, that's 6.5 euros per SPE. I realize it's not 820 euros, it's 800 euros. So we can do a platinum electrode for 8 euros per SPE. I know that sounds expensive on the gold and the platinum, but this is really what's happening to platinum and gold in the world. You definitely do not have to be on platinum and gold. If you're reading a paper, it's easy to just have done it on gold because they know about Cepheid monolayers, but they could have equally done it on carbon. With platinum, sometimes people use platinum because they're using like oxidase enzymes or hydrogen peroxides. You can also use mediators and therefore use carbon. So when you always have a choice to use carbon over gold and platinum, and that choice, whether you can make that choice or not, really depends on how much experience and knowledge you have. Obviously, ZP does put a lot of free knowledge out there to try and help people understand that transition. But my recommendation is always go for the carbon, whatever you're doing these days. People don't value carbon. People really value gold and platinum, so they're always going to have price pressures on them. I think that's what makes ZP a little bit different as well, that this webinar is technical, but you can see that we always have this commercial consideration as well, because the whole raise the debt of ZP is to get people to market. So that's our intention. Just talking about screen printed electrodes, actually, I do get asked this a lot. So if you don't have potentiostats. This is an EIS instrument. Having an impedance enabled instrument is useful because it just gives you more flexibility. I would also recommend, I've already done this, but 300 of our screen printed carbon electrodes is like €250. You really need a cable to go through between the potentiostat, but then you also need a connector. And something I was running into yesterday, actually, somebody had a poor connector, and it was affecting their reproducibility, or their, what I call it, reproducibility. And it was just really because they had a poor connector. So I put a connector here. The connector that I've linked to here is what I describe as a 7mm to 2mm connector, because instruments like Biosensor and the Anapod instruments have 2mm banana plugs. All the electrodes and biosensors I recommend these days have 7mm width, so that's why I call it a 7mm to 2mm connector. I'll try and put I will remember to put the links underneath the video at the end. Question number 2 is about Biosensor. So this is something that we have on our website. I've put a link to it here. And when you read it, it says screen printed electrodes, biosensor activation solutions, calibration solutions, and biosensor data. This Biosensor starter kit has quite a price on it. It's about €2,000. And that's because we were intending for people to have a liquid handling robot. These liquid handling robots cost between €50,000 and €100,000. So if somebody has a liquid handling robot, then the kit makes sense. Otherwise, I would not start by buying a robot. I would start by doing hand fabrication, because if you do it by hand, you can understand the process in your own mind, and then it will give you an idea of what the robot to buy. But let me now break down let me discuss this kit. Let me start with the screen printed electrodes bit. So there's what's in the box: screen printed electrodes, activation solution. The print file is something that people don't need at this moment. I think they're going to need, the things that they're going to need are the screen printed electrodes, the activation solutions, the calibration solutions, and the sensor data. The print file is basically a file that tells the robot what to do. If you don't have a robot at the moment, don't rush out and buy one. Get yourself some manual experience before you buy robots, calibration solutions, and sensor data. Let me cover some of these aspects here. So in terms of the SPE, I realized that I'm going to use the example of a glucose biosensor. So I've said, here is the link to buy, for example, 100 hyper value platinum electrodes. Even though I have just made this comment that you should always go for carbon, when we sell our activation solutions, it's what we call a generation 1 glucose sensor, and the platinums are what's going to work with it. The activation solution, you can buy the activation solution. You can buy, there's 2 parts to the activation solution. And this link, by the way, there is a video on this page which actually shows one of our guys activating and also adding the barrier layer. If you're not clear about this activation solution and this barrier layer, I do have lots of videos about generation 1 glucose sensors on the ZP website. But relative to other things, that's the solution, and that's the barrier layer that you need. Calibration solution, so if you make an electrode, you can actually test it. And data, so the data bit is on all of our biosensor pages. You'll actually find the data. So I suppose I'm saying here is, I've recommended the electrode and I've linked to it. I recommended the activation solutions and I've linked to it, and there's videos on there how to do it. I've shown you where the calibration solutions are and I've linked to it, and I've also shown you here the data, and I've linked to it. Now I'm going to slightly change track at the moment now and go for repeatability. And I really should have used the word reproducibility here. Repeatability is when I repeat something, like repeat, repeat, repeat. That's repeatability. Reproducibility is kind of more like when I make it again and again and again. So I should have really used the word reproducibility here, and I annoyed myself, but that's all right. The one thing I would say about reproducibility is, if you attend one of our FoodSense live streaming demos, and I think the next one's about the 26th of October, you will see that we will do live demonstrations of our product, and you will see absolutely no calibration being performed at that time. And that's because the electrodes underpinning the ZP technology stack are absolutely reproducible. I will now demonstrate that. But it's really important to understand that the reason that ZP has reproducibility is because ZP is the biggest users of our screen printed electrodes by far. When we sell them on the web store, that's a secondary, let's say, income to us. It's us who's using them. So who cares most about their quality? It's ZP. And that's a really different business model to anyone else making screen printed electrodes. They make the screen printed electrodes essentially for you. We make the screen printed electrodes for us, and we share essentially the quality with you, but we do it for ourselves. And I think it's really important. So if I was going to open a restaurant, I would want to make sure that I was eating in that restaurant every day, so that I knew that the quality was high. That's essentially what we're doing. We own a restaurant, we eat in it every day, so we know the quality is high. We make screen printed electrodes, we make sure we use them in our products so that you get the quality as well. And you'll notice in our videos, absolutely no calibration. And that's because we've got such reproducibility. Now let me go into it a little bit and say, look, we obviously make electrodes, I would say, medium-sized volume. I mean, we may make sort of 10,000 at a time. This is nothing, to be honest with you. I mean, this is small-scale manufacturing. Now, what I want to touch upon is we do something called wafer mapping. So we will test them all by voltammetry before they actually enter the supply chain. Let's say we will have tested them. So this here we will often reject sheet one. So we don't ship sheet one. Sheet one is often you're doing a whole series of prints. You don't accept the first sheet because often that's kind of messed up by machine setup. But we know about sheet one because we will have done multiple analysis on that sheet using voltammetry. Sheet two, we will check it, make sure that everything is. This is, by the way, several electrodes. These are not the same electrodes retested. These are several electrodes from the sheet. We'll test another sheet slightly further into the print run. Again, this is not one electrode. This is several electrodes being tested. We'll test another sheet of electrodes into the run, make sure everything's reproducible, and we'll also test sheets later on. And then we'll actually track the entire batch and have a look at a KPI, a key performance indicator, something like peak height, and make sure that our peak height, we think is the median of that peak height is acceptable, and the standard deviation is also acceptable as well. So I was having a conversation yesterday with a client. They have these electrodes. Now they were having a standard deviation of 50%, but I was saying to them, absolutely, the electrodes underneath your, let's say, experiments are really reproducible. It's then your experiment on top of it, which is the irreproducible part. And, I am able to back these statements up with anecdote, i.e. we use them in our own products. You can witness our demonstrations live online. You see that, no calibration, we always get the result. But also with this is essentially manufacturing data. There's actually a Julie webinar as well, that I did state a Julie webinar. These Julie webinars, we do talk about what we call wafer mapping in those webinars as well, and we do live demonstrations on that. When we're doing assay development, I could equally, even though I'm talking about ginger ale here, I could also be talking about non-steroidal anti-inflammatory drugs and stuff like that. This is the kind of data we would be expecting. These are different concentrations. You can see kind of, it's not like our voltammograms here are absolutely perfect, but you do get a sense that our repeatability is not terrible. It's certainly, when I sort of say that the underlying electrodes are kind of 5 or 6%, you need that in order to get this kind of reproducibility. So we were quite satisfied with this. This is like actual sensors made on top of those actual electrodes. So we're really quite happy with our reproducibility. Something I do want to touch upon as well, actually, is not enough people are doing parallel testing when they're doing any kind of biosensor development. So at ZP, we do have a new potentiostat. It's called Emma. In this video, you'll see me turn it around in a minute. But even though it's tiny, I mean, it's much smaller than the laptop that it's connected to. This is a 6-channel instrument. It's really important that if you're doing any kind of electrochemical assay development these days, that you are using parallel potentiostats. Otherwise, you just can't get enough data. We were being shown data yesterday, was kind of 1 or 2 data sets. I mean, when we do data sets, we're we're talking, 1836. We're talking, we want a lot more data than just a few data sets. You've got to be really careful with making decisions on very small numbers of data. And the only way you can really efficiently get to large amounts of data is actually to be running in parallel. So I'll put a link, and I'll make sure I put that link underneath the video as well. I suppose the why question here is, I just talked about reproducibility a lot, and I also talked about parallel testing a lot. And the why is really because the why for us at ZP is because we have a really good way of getting people to either an actual product or what we could call a minimally viable product on a Sense It All platform. The Sense It All platform, it's a bit of a shame in the video that actually the guys plug it into a laptop. They shouldn't be. The laptop was only the power. But this is the, I think the right hand video is better. You can see this generation 4 Sense It All platform. You can see the screen printed electrodes. This means that if somebody's using our electrodes, and they build an assay upon those electrodes, we can put it on this platform really efficiently, and then they've got themselves what we call a sort of MVP, a minimally viable product. So if you want to get this into the hands of clinicians or put it in the intensive care unit or the emergency room if they're in the US, obviously you have to get the kind of ethical approvals and the clinical trial approvals, though you can actually do sort of preclinical work as well, which is slightly lighter. But this platform would allow that to happen, and it's really quite an elegant platform. I'll put a link here. But at the beginning of this webinar, I said, look, there's some free webinars here. It's worth knowing that there's a Sense It All webinar around about the late end of October. So I definitely ask people to sign up for that and see that platform in reality. Question number 4, this is just an interesting one. That on ZP's websites, we do sell glucose sensors, and I have referred to the glucose sensors earlier on in something like question 3 when I was talking about the kit, and they're saying, well, we're testing in blood, can you help us? And I'm like, no, hang on now, stop. When we put products on our website, they're for research purposes only. If you're starting to try to use them actually in medical products, you really have to have a proper conversation with ZP, and actually you have to become part of our quality system. Putting things on the web store in order to allow academic startups start doing some preliminary testing, that's great. But if you're starting to put human blood on our sensors, I would really ask you to stop now. It's I don't want to say it's dangerous, but it's not licensed or approved to do that. ZP, by the way, is an ISO 13485 business, which means we are fully qualified for the contract development and contract manufacturing of medical diagnostics. So we are qualified to do this, and it's with that qualification I'm saying, no, hang on now, stop. Make sure you have a real relationship with ZP. But obviously they do work, and they will work in blood, but we just can't support that sort of going it alone sort of way of working. So I would ask you to stop. Question number 5 is about wearable microneedles. Oh, in fact, I've got one here. I forgot I did. So maybe I'll sort of flick through a little bit and say at ZP, we've got a lot of experience of making. This is it's basically a wearable potentiostat. It's a bit nicer than just a wearable potentiostat. And here's a microneedle array. There's microneedles on this. These microneedles can, it's the nice thing about having the strap is it pulls the microneedles in to the body. And that means then we can essentially deliver our microneedles into the interstitial fluid. Let me sort of illustrate this with a few. This is what the setup's like. You've got electrical contact here. We've got the sort of the needles come to the watch, but this is a sort of a semi-disposable part, and the watch is not disposable. That's a good business model. Otherwise, you don't want to be disposing of a lot of battery, PCB, and plastics every time you want to replace the watch. So this is some close-ups of the technology that we have. Here's a close-up of some of these needles. So ZP, we've got easily over 5 years experience on this, tens of thousands to hundreds of thousands of hours worth of experience. We have a class 7 clean room with class 5 zones, which is an aseptic environment, so it allows us to do the functionalization and contract manufacturing of these kind of microneedles. So we're very set up for this and also for human use. And the technology that I am showing here, it's defended by at least 50 patents. So it's a very, which we own. So it's a very defended technology. Now, our business model is contract development, contract manufacturing. So as long as you're well funded, you've got to understand that, the upkeep of 50 patents is over 100,000 a year, let alone all the cost of actually developing them, but just the support of those kind of patents. So as long as you're well funded, then ZP has a technology stack that's really useful. This is a close-up just to kind of show. These are not painful, by the way. I mean, this is my arm. I can push down this really hard. You don't feel this, but the microneedles essentially go through the skin and deliver, let's say, the sensing layer into the interstitial fluid. So let me just do a quick summary. So today I've talked about hypervalue electrodes. I've talked about our working being either carbon, platinum, or gold. If you've got a choice, please use carbon. I've talked about the reference being silver chloride. I've talked about the counter being silver chloride, and I've talked that it's not by accident that they are. The gross dimensions of that, the width of our electrodes is often, or our screen-printed electrodes is often 7 millimeters. The length is 25 millimeters. The thickness of the material is about 625 microns. The Biosensor starter kit, which was question number 2. I've literally said, look, if you don't have the robot, don't rush out and buy the robot. This will cost you between 50 and 100,000 at a minimum. You're starting, you can get higher throughput robots, which are $250,000 upwards. But I would say I've linked to the platinum electrodes. I've linked to the activation solutions. I've linked to the calibration solutions. And I've also shown you where that you can find the data. If you need support from ZP provides support through contract consulting or consulting. I don't like the fact I've used the word repeatability here. Should have really used reproducibility. But underpinning all of this technology, I would describe ZP as a sensor to API company, which means we make sensors, we make electronics, we make cloud apps. We do all this as contract development, and we have a cloud where the data can go. And on that cloud, you can use what's called an API call, an application program interface. Again, we do webinars specifically on this, so it's probably worth attending those. And all of that is underpinned by this concept of reproducibility of the electrodes. It's really important to us that we do have that. Testing blood. ZP does a lot of contract development with companies where we are testing blood, urine, sweat, tear film, a lot of things. Saliva is a good one as well. But please don't go alone with this. If you're using ZP technologies, don't go alone on that. Using ZP technologies to make decisions in humans. I don't want to say it's dangerous, but I cannot condone it. You have to have a proper, contract with ZP and doing this in a proper program. Wearable microneedles, yeah, we're very experienced in it. Thousands of hours of experience, and also backed up by the hardware, the sensors itself, actually the ability to manufacture this, and obviously a deep patent portfolio on this as well. So I want to sort of wrap it up there and say thank you very much. If you've got any questions with ZP, don't hesitate to reach out to us. We do this webinar every week, but I would also say there's one of the links that's in today's webinar shows you big webinars that we do on different aspects of our technology. So I hope you can attend one of those as well. Okay, thanks very much.